All right. So, first things, today we're going to finish up this lecture, and then on top of that, a little bit about the schedule going forward. So, Wednesday, we will have our usual review session. So if you haven't already gone through the FAQ and the topics of interest documents, please do so. And if you cannot attend the review session or choose not to, remember, standard advice I give everybody about how to do well on the exams. Number one, well, I just put, for every term or concept in the TOI, number one, be able to define it, right? And it's less about memorizing the definition, but, have a definition, know what it is. Number two, be able to provide an example, right? Number three, understand how it's used. And number four, understand why it's used that way. Now, of course, 3 and 4 may not always be applicable in that exact way. For example, if we're talking about deadlock and live lock, we would, instead of talking about how it's used, we would say stuff like, why it's a problem or how it can arise. Okay? But this is the idea. So for everything in the terms and definitions, don't just know the definition, but understand something more about it. And then hopefully you'll do fine on the exam. All right. Anyway, all right, so let's get on with the lecture then. So where we left off was talking about service-oriented architecture. And service-oriented architecture basically means instead of having big, giant applications with lots of pieces, you have systems built up of small modular applications that have standard ways to exchange data. All right, I'm going to draw a picture now. I'm going to do it a little bit out of order of how I did it this morning. But all right, we're going to draw some boxes, and then I'll explain what the boxes mean. It's going to kind of look like Purina dog chow in color, but that's okay. All right. So this I don't know why the colors are so hard to change. This is a big monolithic application, okay? And monolithic just means it's a single piece. Mono for one, lith for rock, so it's like a single chunk of stone, all right? And all of these different modules within the application, there's a process. So suppose Amazon had a system like this, and it was all internal in the sense that it was one big application. It was all internal in the sense that these parts of the system aren't really modular, right? There's some sort of mechanism coded in there by which they exchange data, but these are a lot of tightly coupled components. Remember we talked about tightly versus loosely coupled stuff? So loosely coupled, the one side of the operation doesn't need to know the other side does stuff. Here, we're talking about tightly coupled components, so they do need to understand. The problem with this kind of system, all right, with this kind of monolithic, tightly coupled application or system, a change in any one part of the system might render other parts inoperable. Okay, that means suppose you have some process like red is expecting to receive data in some standard format, which is then going to send some result to orange, which then sends some result to yellow, which might send it straight to blue, or might go to green, which then sends that result to blue. Okay, that's the sort of thing. Now, what that means, if you change something, say, in the yellow box, all those other boxes, you got to carefully go through those and see, oh, did this change to the yellow box mess up anything else that we're trying to do here? And when applications are designed this way and they get very big, you have to be very cautious about making any changes at all. Because making a change that could potentially stop your system from working, number one, you don't want to go through that process very often. And number two, you got to be very careful if you do change something because you have to. However, In a loosely coupled system, and I might add here, based on modular services, even though that's somewhat redundant, right? You would be confident that a change in one module wouldn't affect the rest of the system as long as the interfaces don't change, right? And this is kind of the example I gave the other day where I talked about a credit card transaction, right? So you have a credit card, Amazon is sending some credit card transaction to Visa, say. And Visa has an interface. There's a standard batch of data that Amazon's going to send for a transaction. If Visa wants to change its fraud detection algorithm, that doesn't affect in any way what Amazon is sending, right? Amazon doesn't need to change anything internal to its systems because that's a modular service. It just says, hey, send me this credit card information. I'll run it through my own process, and the output will be a thumbs up or a thumbs down. That's modularity. That's loosely coupled. And it's a lot easier to modify parts of a system like that than it is, something where it's a single unit. But I will also add on the topic of service-oriented architecture, suppose you have a module here that we'll draw, we'll fill that in with green, and green's not really working out very well, but you found that there's another substitute you can make, right? So we're going to X out green here, but there's a substitution you can make. Somewhere in a cloud operation, there is an alternative module, which we'll draw like this, and it's somewhere else, right? It's not under your own roof. It's not part of your application. But you know what? Yellow could send data to that, and that could do the same work much faster than your old green operation is doing. So this kind of loosely coupled modular system based on services also allows you to pick up modules from anywhere. They might already be available in the cloud service you're using, or you might borrow them from somewhere else. I don't know, like GitHub or something. I don't know, whatever. Okay. And a real world example of this, okay, because I know you're like, well, give me a real world example. Okay. Intuit. All right. So Intuit went to cloud, fairly early and fairly totally because of the nature of the tax software business, right? It's busy for a short interval through the year. It's pretty, quiet the rest of the year. Now, so that's, that was what was really driving them to shift a lot of their services to cloud, so they didn't have to pay for a bunch of hardware throughout the whole year that was mostly just gathering dust. But Intuit wanted to do something else. They wanted a natural language processing feature to help with database queries. Okay, so natural language processing is just like the stuff you do when you type a search query into Google, or you ask your Alexa at home, your Amazon Dot, to serve some content up for you. It basically understands what we say in more or less the way humans talk. Okay, that's what natural language is. Now, if Intuit designed it at home, would take years, right? They estimated, maybe 3 to 5 years, which is a long time for this sort of feature that they want fairly urgently, because people go to Intuit saying, hey, I have a small business. What forms am I probably going to need? Or can you send me the complete batch of 2020 forms, your basic schedules, so I can do my personal tax returns, right? Natural language queries like that are pretty common. People want to be able to look up stuff that way, get the results quickly. But Intuit wasn't in the natural language programming game. So yeah, they could have eventually done it, sure, but it's a lot of work to design something like that, right? And they would have had to get help from, consultants that are expensive and all that. But since they had this sort of setup, right, they broke it into a service organized thing with a service, I'll say NLP, natural language programming, module available in the cloud, right? They tried out a bunch of them, they picked one, they tested it out and figured out how to interface it with all their systems. They were able to have it running in a few months. And I should add months, and probably much better than an in-house design, right? Because again, they went and they looked through a whole bunch of different options before they finally settled on one. So these are the kind of advantages. I mean, again, we talked about cloud. It helps deal with variable demand because the cloud service can provide, all the system capacity you need cheaper than an ordinary single business can. But there's also features like this that if your system is already designed with service-oriented architecture, you can take advantage of other components available in the cloud. They don't have to be under your own roof. You can have components available in different parts of one cloud or even entirely different cloud systems. All right, does that make sense? I hope that makes sense. Okay. Would you like to know more? All right. Well, that's fine. So this is all the stuff that's on the cloud on this slide here, right? Cloud systems tend to be built on the foundation of service-oriented architecture. I mean, the systems themselves, but the usage of them, it also works a lot better if you're using SOA, right? So services, small independent application with inputs and outputs specified by interfaces, and you build bigger systems out of these small independent units. So service-oriented architecture, especially combined with the cloud, your services can be located anywhere. They don't have to be under your roof. It's easier to modify them because they're modular, right? This is all the stuff we talked about. Or you can just reuse them without modification, right? If you want to implement some feature in your system, you can just look around and say, maybe somebody's already designed one that's going to work just fine for you. Okay. Again, what makes an application a service? Well, the components of the application work as modular objects. They exchange data over networks. And again, they require standard input and output formats. So building on that, again, most of the time these services are going to be exchanging data over the internet, right? I mean, if you're designing a system in-house that's all on your own hardware, yeah, you don't need to go to the internet for that. But anytime these kind of services are exchanging data over the internet, they become what are known as web services. And web services tend to be platform independent. What they do is the interface has defined some object format, whether it's in XML or JSON. So there's an input format that one application expects to get, and there's an output format that the other application expects to receive. There used to be an example here for conversion between temperature scales. Seems to have been removed. Let's see. I am not able to find this one anymore. So they talk about it, right? But I don't have a way to actually run it now. They've switched how it runs. Oh, no, there it is. There, I found it. Okay, so this is it. If you wanted to lift this code, right, you could do this. I guess I could just lift this. Here. I wasn't thinking the other day. I'll just do their try it now. Try it yourself. W3 schools, try it yourself. I was baffled this morning. I was like, where did it go? But all right, so hopefully this all works. Okay, great. So I can do Fahrenheit to Celsius, Celsius to Fahrenheit, right? Now it's obvious that there's no process in this web page that's what's happening, right? All there is, oh, thank you. All right, once one person says it, cool. Okay, so all there is, there's a form here, and you can see that there's no math about converting Celsius to Fahrenheit, right? And there's another thing here that this is a different form. So whatever thing I send in the form, it's going to go to this. One of them will go to this Celsius to Fahrenheit conversion. The other one will go to this Fahrenheit to Celsius conversion. All right, so we're going to make this work today. So let's say it's like 50 degrees, and we want to see what that is in Fahrenheit. So I click there. This is a web service. It sends the result. Number will probably be something like 20. Let's see. Mother. All right. Try you then. Let's see. All right. All right. Well, like I said, it's not working as well as I had hoped, but there it is. I'm going to try to implement it right in the web page here. Let's see. Maybe this will work. Oh, yeah, there it is. 10. Okay, so there it gave the result. Hooray! It's a Christmas miracle. Okay. Anyway, but that's the idea with web services, is they exchange data over the internet, and that data, follows some standard format rules. So in the case of what I was sending, Obviously, I had to send a number. I couldn't just write out, the quick brown fox jumped over the lazy dog and convert that from Fahrenheit to Celsius. Likewise, the response I get back is also going to be in some kind of numeric format. Okay. All right. Again, all this stuff we mentioned before. Once an enterprise adopts SOA and web services as its standard, number one, it becomes very easy to divide your applications into smaller components, right? Because if your applications are built from these services in the first place, it's no problem to break them back apart into services. It's easy to transfer components to the cloud, right? You can put some services in the cloud, keep some of them under your own roof, or you let the cloud deploy all your services wherever they need to go. And again, like the Intuit case, you can use other components that are available in the cloud. So, simple example, right? Salesforce is a website where you might choose to advertise some product you're selling, but you're actually allowing people to buy that product through Amazon. Salesforce isn't the best site for, large-scale transactions, just like Amazon isn't the best site for advertising. Billed through Chase Bank. If somebody goes to Amazon and buys the thing, Amazon's not running its own credit card services under its own roof, right? Somebody might buy buy your item with some Chase Bank credit card, and then, Amazon has to send that information to Chase, which then sends back a thumbs up or a thumbs down. And then once that's verified, then Amazon can schedule it, say, UPS. If the user has picked UPS, then Amazon can arrange for that delivery and can give you a tracking number and take care of that stuff. But again, even though Amazon has its own shipping services, not all their shipping happens through Amazon, right? They could use UPS for some of these things. All right. Next stuff, cloud migration. So cloud migration is the process of moving applications and or data to the cloud. Sometimes you just want to move data. Sometimes you might want to move just applications, but quite often you want to move both. So talk about some of the common models. Number one, data only. So it might be a case where you have large volumes of historical data that you're not really, you don't want to make some massive system where people can retrieve this stuff quickly, right? So you have to keep it, but you don't really want to keep it under your own premises, and you don't want to design some massive system where it can be easily accessed. So you might say, I'm going to store all this data in the cloud, then the cloud will manage those concerns, right? And the cloud will manage backups and everything else, so you don't have to add extra network capacity for that. Number two, machine replication, which we've talked about. So machine replication is simply making a copy of your existing system in the cloud. If you have 20 servers running some mix of applications and processing some mix of data, that's basically the exact same system you would port to the cloud, as close as you could match it. Advantage of machine replication, it's very easy to test, because if the system is well designed and works well under your own roof, and you're basically building a copy of it in the cloud, then it ought to work well there too, right? The downside, like we talked about, is that you're not going to take full advantage of the cloud's ability to save you money through virtualization. So the last one, physical to virtual, or P2V, that separates applications into components for easier virtualization. And the example I gave, maybe it was Monday, maybe it was Friday. Suppose you're an organization that has 1,000 licenses for Microsoft Office. Well, maybe you don't need 1,000 copies of every application in that suite, right? You just need a few at any given time. So you put those applications on some servers when and where you need them, and that's going to keep your costs down because you're only requiring the software and hardware that you need when you need it. All right. Now, of course, there are concerns with migration. And these were bigger like 10 years ago. Things like it would take a very long time to deliver your data to the cloud. What do you do if your organization is having trouble keeping up with the data flows, and then you have to, number one, process all the data that you're already getting, plus number two, maintain a continuous flow of data to the cloud itself. Yeah, that can be kind of a hassle, but these things, they're not so bad these days. But you can still have these kind of problems. So what happens to your organization during migration, right? While you are maintaining your existing system and sending data to the cloud, there's going to be a heavier than usual system load. And number two, what's your fallback plan if migration fails, right? If something goes wrong for some reason, what do you do? Do you give up? Do you try again? Try to figure out what's wrong? go to a different cloud provider. And funny thing, this is actually a lot of what my wife does. The projects that she's on, she does access and identity management for Accenture. So basically, you know, access credentials and things. And always when they're deploying some new application, right, there's always some problem, because these systems are complicated. There's always some problem where one part of it isn't connected the right way it's supposed to be, or one part of the system is sending data in a format that's not specified. I just overheard one of her calls a few days ago where there was somebody who was, he really took him a long time to say it, but he said, you know, well, there's this one application and, you know, it's expecting to send out a text string, but the application that's receiving it actually is requiring it to natively be in some kind of numeric format. And so there's a mismatch there. And I was like, wow, it has taken you a really long time to just say type mismatch error, right? But I don't know, maybe he was talking to a lot of non-technical people, but it really, it seems slow. Anyway, but this is the sort of thing that happens all the time. The applications are linked incorrectly somewhere, or you might have one application already using an application port, and then the guys that are doing the migration, they set up the system so that another application is using that same application port, which can delay things. Anyway, problems can happen. Okay. Now, next thing is talk about 3 basic models of cloud services. So I'm just going to put them in Paint first, and then we can come back and talk. So the first one we're going to talk about infrastructure as a service. And infrastructure as a service basically means you get hardware and nothing more, right? So no operating systems, no applications, nothing, okay? Now, the good side about this, you are free to include any mix of operating systems or applications, including, you know, weird ones. So if you want to use some out-of-date operating system, like maybe Windows keeps telling you to convert to Windows 11, but you're like, no thanks, I'm real happy with Windows 7. If your organization wanted to do that, they could. If for some reason your organization had unique hardware problems and they wanted to design a custom operating system for added security, they could do that, okay? Or you could have machines that have multiple operating systems on the same one, whatever. Same thing for applications, right? Anything you want to design as an application, if it can run on the operating systems you have, that's fine, you're good to go. The downside, the bad, management headaches, right? All that work must be done by you, including updates. Okay, so not only the installation of the operating systems or designing the applications, but the perpetual problem of updating them, that's on you. So you have maximum flexibility, but what else do you have? You have maximum headaches. Okay, not every organization wants to design its own applications. And certainly most don't want to design their own operating systems. All right, next one, let's do it in orange, that's fine. Okay. So the next one, platform as a service. Okay, with platform as a service, you get hardware plus operating systems plus maybe a vanilla database application, right? So if you're, for example, using Oracle's cloud service, Oracle's big in the relational database industry, they might give you some very simple basic vanilla database software to go with the platform, right? But in general, you don't get much in the way of applications. So the good, you can include any applications that you pick or design yourself, all right? Again, the bad, application design and management is your problem, okay? Not the clouds. So platform as a service could make sense if you have a number of custom applications that you've designed and you want to use them on somebody else's hardware. Okay, and I'm going to draw a box around the whole thing because when you get platform as a service, you get everything that's included in infrastructure as a service plus a little extra. Last one, software as a service. So with software as a service, you get hardware plus operating systems plus apps. The apps are already there, right? I'll give an example, like on Facebook, right? You go to Facebook, you don't have to do anything special to install, the ability to make wall posts or, to upload photos. All right, now there is some flexibility with software as a service. There may be applications that have an opt-in feature, just like on Facebook, you can opt in to instant messaging, but you don't have to, right? That's not something that everybody does. So the good for software as a service, easy to use. Everything is already there and up to date, right? So you don't have to mess around with updates, installation, whatever. You just show up and use what's there. Downside, the bad, you are limited to what's there, right? So there's going to be some list of options. You can, pick and choose some mix of them, but what's there, it's there. It's like going to Panda Express, right? They have a lot of different kinds of food, but if you want a burger, you can't get a burger there because that's not the kind of business they are. They're not in the burger business. All right. So, all right. Now, somebody asked in the morning class about SAP, which does Enterprise Resource Planning. Again, Enterprise Resource Planning is one of those software things where there'll be a lot of different modules, and not every business needs every module, but at the core, it's still ERP, right? So you have a selection of different ERP options, but you're not, as far as that software as a service is concerned, you're not going to get something else, right? You're not going to get like instant messaging or Angry Birds or whatever. It's just ERP. Okay, because if you did have the ability to include new applications, it wouldn't be software as a service. It would be platform as a service that happens to have a couple things already there. All right. I mean, I guess you could argue that there is potentially some kind of middle ground if you said, well, I set up a platform that has a bunch of software there, but then the people can also add stuff to it. I'd say in flavor, that's more like platform as a service, because then the expectation is that's what people will do. Yes?
Yeah, so like infrastructure as a service and platform as a service and software as a service, so they're all like interlinked, like they all build up on top of one another.
In a sense, right? Because infrastructure, you get the machines. Platform, you get machines plus operating system. Software, you get machines plus the operating system's already there, plus some apps. That's why I draw the boxes the way I drew them. Yeah. Cool. Anything else? That's good. All right. So this is an obvious candidate for one of those things, alikes and differences, right? How are these alike? How are they different? What are they? How are they used? Why are they used that way? That sort of thing. All right. Anyway. All right. Boom. Okay. So, I don't have the slideshow. Okay. So that's basically what the models are. I'll just mention them again. So with infrastructure as a service, you get the hardware, right? Users, though, are responsible for everything. Platform as a service, you get a platform for deploying applications, right? The hardware's already there. The operating system's already there. It's like you went down to Best Buy and bought a new laptop and you can install your own applications on it. That's great, okay? But there's less control because you can't, switch operating systems or do some customization there. But it's also easier to work with because all that operating system patching and everything else automatically happens behind the scenes for you. Okay. And software as a service, again, the applications are delivered to you through some existing platform. And you show up and use it, but what's there is there. Examples of that, Microsoft Office 365. It's not like you could insert a new application into that group. G Suite, anybody know what G Suite is? You use it. Yeah, it's Google. It's got Gmail and Drive and all that. Everybody here uses Gmail, so I know you all got G Suite. All right, so that's another one. Again, as far as G Suite, what's there is there. All right. Okay, a few more things. We'll talk about cloud. We'll talk about cloud services generally and comparisons and all that. So, first of all, relative to doing the same work under your own roof, cloud services are not terribly expensive, right? I mean, you can spend a lot of money on cloud, sure, but you're probably going to save, if you're a business that is experiencing strongly variable system usage demand, you're probably going to save money going to cloud. So that's what I mean when it's not terribly expensive. But there's some problems. Number one, the vendor selection process can take a while because the way things are in the corporate world, you don't get to be some low-level person who just makes a decision, right? You gotta get something from top management who says, hey, we want to switch to cloud, and then people above you are going to say, okay, look into some set of cloud services and give me a recommendation. And those people are going to forward your recommendations up, and somebody higher up is going to have to sign off on it after having done due diligence and covering their ass and all the rest. So this sort of thing, it's not like for a sole proprietorship where, you know, it might be you and like 5 employees where you just pull the trigger and say, yep, we're going with Microsoft Azure, right? Big operation, decisions are more complicated. Number two, it's hard to learn about differences between cloud services without direct experience, right? One example is that different organizations are going to have different problems and need different features. So that's something. Another is that problems that only happen once in a while, you tend to get a wrong idea of how common they are. So simple, and this is basically sampling error. This is a sampling error problem. So suppose there is some cloud service problem that in reality has a 10% chance of causing severe problems for an organization like yours, okay? The real true probability is 10%. But suppose you only identify 5 other organizations closely comparable to yours, where you can find out if they experienced the problem, okay? So about half the time, you'll see none of them had the problem, right? And you kind of won't even really be aware that it's a thing. Also, close to half the time, you'll see exactly 1 had the problem, in which case you'll estimate the probability of the problem at 20%, right? 1 out of 5. You'll be overestimating. And there's even a small chance that more than 1 had the problem, and you'll massively overestimate its likelihood. Okay, so this is a problem that commonly happens with small sample sizes, right? It's not necessarily going to be that easy to find a lot of comparable businesses using some cloud service, and they're both similar to your situation, right? And you have that information. And then I'll add as a follow-up and multiply that sampling error by all the different problems that could happen, right? It's very probable that your estimates will be off. So that's saying, and estimates in a lot of different aspects. So it's difficult, you know, to really super optimize this by going into great detail and saying, I'm absolutely confident that we have made the best decision. It's hard to do. Information is limited. Finally, security policies and technology are hidden, right? It's not like you can peek behind the curtain at a cloud service, see exactly what kind of security they set up, do an audit on them, see how it's going to affect your systems if you deploy them there. So this is a problem. They're difficult to compare. Now, in principle, everybody understands that it would be great to have some cloud version of Consumer Reports that went into detail about every possible aspect of cloud computing so that you can make an informed decision, right? But it's just not feasible because if nothing else, besides the problems of opacity not being able to peek in and the fact that it's complex, there's different category component weights, right? What's a very important concern for your business might not be very important for somebody else's, right? A large banking operation is going to be way more concerned with system security than, say, a small scale pizza delivery service, right? They're just not going to worry that much. Anyway, because, I mean, free pizza is nice, but they're probably not going to be a prime target. Another thing, your business may not even know exactly what it needs from the cloud, right? Especially if it's a small business or if it's your first foray into cloud services, yeah, you might not know exactly what you need. However, one thing the businesses have and can look at very easily is the cost, right? That's the one thing businesses are always going to ask. Well, we don't know exactly how well what we're going to get is going to fit our business, but we do know what we're going to spend. And there's two basic models for that. Number one, usage-based. So usage-based works good with virtualization. It's the idea that you just pay for what your applications do. So if it's in terms of system storage, if it's in terms of CPU cycles, it's in terms of network traffic, you'll get charged somehow based on that. And typically, because it's virtualization, your resources are going to be shared with other cloud users. So again, you're going to have those co-tenancy concerns. The other one is time-based. So in the time-based model, basically you have some set of hardware resources that are specifically available to you and only you for some specified amount of time. And because of that, you're going to pay for the resources, right? You're not going to pay as you go in the sense of how many CPU cycles your applications are using. The cloud service is going to say, well, you rented out 20 servers for a week. Doesn't matter that much if they were busy or not busy. You still rented out 12 servers that we couldn't use for anything else, so we got to charge you for that. Now, if you're interested, I have some links here to some real-world cloud service pricing. All right, so if you want to look at something like, we're going to do the oldest first. All right, so here are some of their basic ones, like EC2. Just to give you an idea, not even digging deep, but one thing that's a basic split to start with is on-demand versus spot. So on-demand basically means you get the system capacity you need pretty much exactly when you need it. Spot instances are basically like flying standby. Yeah. Oh, screen, thank you. Yeah. All right. So on demand, again, you pay for what you need when you need it, and it's there right away. Spot is like flying standby. So if you have something that's not immediately pressing, like doing some kind of database synchronization, right? On demand, that would be transaction processing. You want that to happen right away when the transaction begins. Spot instances, you know, if you say, well, we have this large database and multiple replicas, and every now and then we got to check and make sure that none of the replicas has, you know, gone awry. You could do that with spot instances, right? Because it's not super urgent. All right. And just digging down through that, if we wanted to do this, I could see on-demand pricing, for example. And just this one part of one system, right? And we're specifying a single location type and a single region and a single operating system, right? There's a lot of options, right? But again, there's a whole lot of different options. There's a whole lot of different cloud services. So if you're a full-time cloud service guy and this is what you do, you're going to be familiar with this. But if you're a business that has never done this before, yeah, you probably want to hire some consulting services from full-time cloud guys who can help you navigate this. All right, because it's not simple. Okay. Next thing. So again, cloud service rates often complicated to compare even within a single provider. But even, right, that's bad enough. But then you try to compare, you know, Microsoft Azure versus Amazon versus, I don't know, versus Google versus IBM. It's not going to be a perfectly apples to apples comparison. There's always going to be some kind of differences in the hardware you get or other issues like quality of service, reliability, whatever. So it is much better to consider cloud services in terms of fit, right? So for your business, try to identify which cloud service provides all the capabilities that you think you're going to need for the near future and pay enough to get that. Because again, it's going to be cheaper than what you're doing under your own roof, but going to cloud, you want to make sure that you have everything you need, that you're not giving up things that you do need. All right. Last couple slides. So about 10 years ago, there was a fellow who wrote an academic research paper that was basically some kind of cloud services consumer reports wish list of all the things you would like to know in order to make a more informed decision about which cloud service to use. So one of those is accountability. So things like audits, are they regularly audited and by who, and are the auditors neutral? Are they compliant with basic, security and data privacy issues? And who owns the data, you or them? So this is an interesting thing. So Google Analytics, for example, is a web analytics operation, web analytics service. In the free model, which is very popular, technically Google owns the data. So if Google somehow loses your data, they say, oh, sorry, that last month of data of people visiting your website, oops, sorry. And you can't really sue them for damages because Google provided the service to you for free. So, it is what it is. Likewise, Google can fairly arbitrarily change the terms of the contract. They can say, we used to offer 5 years of data that we would store. Now we're going to dial that back down to 18 months. And there was a window where I saw that happening when I was teaching web analytics. But if you shell out for the premium version, Google Analytics 360, which costs 150 grand a year, then you're paying for something and you have a lot more, the data is actually yours. So Google can't arbitrarily change the terms of what's available. They have to keep all that data available to you, or at least offer you the option to download it within a certain time before they get rid of it. All right. Other things, agility, which is the speed of integrating new features, right? Or elasticity bounds. How quickly can you change the terms of the contract? Is it possible to go from one server on day 1 to 100 servers on day 2 and back down to 1 server on day 3? Is that feasible or not? Cost is pretty objective. Businesses can always see what they're paying for what they're going to get. Guarantees, things like service level agreements. So the cloud service is going to say stuff like, our system is going to be available 99.99% of the time. If it's available less than that, we'll compensate you in some way for our failure. Performance, things like what features are available, how fast you can pull data from the cloud, things like that. Of course, security, right? You can learn something of that by looking at their assessment results, looking at their history of data breaches. Hopefully you have some idea of how well they're doing in terms of privacy. And last one, usability, right? How easy is the cloud system to use? Bearing in mind that ease of use is very relative, right? If you're a full-time cloud service guy, what you consider easy to use is going to be different from 75-year-old grandma selling stuff over the internet for the first time, right? So, all right, last slide. Thank you all for sticking around. 2 facts. Number 1, cloud security overall is better than most information systems had by its customers. But you can't peek behind the curtain. It's opaque, so you don't really know. And number 2, we also know cloud operations are not invulnerable against security threats, right? There were the iCloud hacks. So I know people have some knowledge of them, even if it's only secondhand. But the story of the iCloud hacks was around 2010. There was this co-tenancy issue where different people, hackers were able to figure out how to breach the bounds of the data they were supposed to access on a particular machine, right? So they were able to run these malformed queries that Apple didn't detect as being malformed, and they were able to access data they shouldn't be able to. Well, the interesting data they mostly ended up getting was nude pictures that people were sending to each other with their phones, including those of many, many famous people. So that was a big thing, and Apple was quite embarrassed by the whole operation. So yeah, cloud operations, they have pretty good security, but they're not invulnerable. Things can and do go wrong. So overall, going to cloud, security risks, they're probably going to go down for you, but it's hard to say exactly how much. And there are some unique cloud-specific concerns. Number 1, data leakage. If there's a breach in your own organization, in theory, you have access to all that network traffic data, and you can see that there's a breach and decide what to do with it. In the cloud, not so much, right? The cloud is going to have access to that data, and you hope they detect it and stop it, but if they don't, then yeah, that's a problem. Number 2, like the iCloud hacks, anytime you're using public cloud and there's co-tenancy on a machine, there's the possibility that people are going to be able to access data they shouldn't be able to. And the last one, deletion assurances. So Imagine you've been working with Microsoft Azure for 5 years, and at the end of 5 years, you say, well, Microsoft, thanks, it's been great, but we're switching over to AWS. And Microsoft says, don't worry, we're going to delete your data. And you're like, well, thanks, but I'm feeling a little nervous with those finger guns. And Microsoft says, nothing to worry about, buddy, we got you. And you're like, I am not comforted by this, right? And the thing is, we're going to assume that cloud organizations do genuinely intend to remove all your data, but failures happen. There are some famous cases with Snapchat. So in case anybody doesn't know, Snapchat's special feature is that any pictures you send are automatically erased within like 30 seconds, something like that. But they found cases where these images were replicated and not all the replicas were deleted when the time ran out. So they were still potentially out there. Again, these problems happen. Cloud systems try to keep them from happening, but anytime there's going to have a system, there's potential for failures. Okay, that's all I got. It's been a hoot. We'll see you next time. It'll be a review session. Thank you.